Hi, I'm David Andine, Director of Reference Designs here at Maxim Integrated. And today I'm joined by Suravi Karmacharya from Worth Electronics Midcom. Suravi, thanks for being here today.
Thank you, Dave. I'm glad to be here.
So today we're going to talk about MaxRefDes 67, one of our latest high-performance analog input reference designs. This design is a universal analog input, meaning that it can take in both industrial current and voltage signals, as well as RTD and thermocouple signals. This type of configuration is especially popular in industrial applications because of its flexibility.
So what makes this one special?
Suravi, there's really three key features that make this reference design special. The first one is that it's entirely software configurable, so no jumpers are required on the input. If a person wants to go from, say, a current input to a 2-wire RTD input, all they do is change the wires that are sending in the signals. They don't need to change any jumpers. This makes configuration and reconfiguration much simpler and saves customers time.
So how do you achieve that?
So we've achieved the software configurability by providing switches on the electronic side of the board that do all of the signal switching on our side of the signals.
Well, yeah, software configurable, that makes sense to me, but don't all of those switches compromise system performance?
That's a good question, and that actually leads me into our next feature. At the heart of this signal chain is our 24-bit analog to digital converter. So we have a very, very high accuracy signal chain. And in performance testing, we've achieved over 22 effective number of bits performance. So these switches don't compromise system performance, and that's as accurate as you'll see on just about any industrial system.
High accuracy, I like it. So what's the final big feature?
So the third key benefit of this reference design is that the signal chain is designed with entirely beyond the rails products from Maxim. Beyond the rails is a feature in our parts that allows the parts to accept signals, currents or voltages, that are of greater or lesser values than the voltage used to bias the part. So for example, on this design, we can accept both negative and positive current and voltages on the input, and yet we're not generating any negative rails on the board to bias any products. This saves space in the design, but also saves a tremendous amount of cost because of components that don't need to go on the board.
Yeah, wow, that's a big benefit. I can already see how your customers can save the board space and money.
Exactly. So enough about what we've done on this design. Suravi, let's talk about Worth's contribution to this design.
Thank you, Dave. Yeah, great. So Worth Electronics Midcom supplies a high-performance electronic component that goes into a variety of systems. So we specialize in custom magnetics and custom transformers. So for your MaxRef Design 67, we built our transformer 750-315-319. This transformer works with your IC MAX17498C flyback converter, and this provides an isolation of 3.75 kilovolts across a gap of 2 millimeters. In fact, for this design, Dave, we actually used our low-profile package. The maximum height of the transformer is only 5 millimeters, and it also provides a creepage clearance distance of 2 millimeters. So this low-profile package from Worth Electronics Midcom actually provides you an opportunity to build smaller and slimmer modules, especially for industrial applications.
Fantastic. And with this transformer from Worth Electronics Midcom, at the system level, we've been able to achieve 300 volts RMS working isolation with pollution degree of 2 and a material class 3B, all in accordance with IEC 60950. Suravi, we really appreciated working with you on this design.
And thank you, Dave. It was a pleasure working with you too. So before we go, let's see how this works.
Absolutely. So here's the design itself, and you can see that we've connected lines for communication and power, and we have a thermocouple probe attached to it. If we look at the readout on the screen, we see that the temperature is roughly room temperature. As I dip the probe into the ice water, the temperature drops drastically, and you can see the accuracy and resolution by which this design is measuring that temperature.
Wow, that's high performance with great accuracy.
Absolutely. Well, Sarabi, thank you so much for joining me here today. We really appreciate it and really appreciate working with you on this design.
Thank you so much, Dave.
And thank you for joining us today. For more information, please visit www.maximintegrated.com and go to the Reference Design Center where you can search for MaxRefDes 67. Thanks so much, and we'll see you next time.
Thank you.